In this video, you will learn how to solve problems in stoichiometry. A technician analyzes a sample of water from the tailings pond of a mine for the presence of mercury. After treating and concentrating the water sample, the technician carried out the titration reaction. So we're given here the reaction to form mercuric chloride. A 25 milliliters sample of water containing mercury reacts with 15.4 milliliters of 0.0148 molar chloride. This is chloride. As sodium chloride. What is the molar concentration of the mercury in the sample, and what mass of mercuric chloride is formed in the reaction? Now, to answer the first question asking for the molar concentration or the molarity of mercury, which has a unit that is equivalent to moles per liter. So we notice here that the given volumes of water and sodium chloride or chloride in sodium chloride are in milliliters, so we need to convert this to liters. So we convert 15.4 milliliters to liter. So there is 1000 milliliters in 1 liter, so this is just equivalent to 0.0154 liter. And for the 25 milliliters, we convert this to liter as well, and this is just equivalent to 0.025 liter. Alright, now that we've already converted the volume into liter, then we can now compute for the molar concentration of mercury in water sample. The first thing we do is we get the number of moles of chloride in the chloride solution, which is given as 0.0148 molar. So we multiply the volume of that concentration by its molarity. So that would be 0.0154 liter times 0.0148 molarity, that is mole per liter. Right, so this is chloride ion, and then we multiply this by the mole ratio. The mole ratio of mercury and chloride. So from the reaction we have from here, we have 1 mole of mercury is to 2 moles of chloride. Right, and this cancels out the units. Then we are left with the number of moles of mercury. So let's compute this. 0.054 times 0.0148 divided by 2. Then we get 1.1396 times 10 to the negative 4 moles of mercury. And now we need to find the molar concentration. We already have the number of moles of mercury. Then to find the molarity, we need to divide this by the volume of water to get its molar concentration. So we divide this by 0.025 liter. So 0.025 liter. Then we get, let's do this. Okay, so that is 1.1396 times 10 to the negative 4 divided by 0.025. Okay, then we get 4. So this is just equivalent to 4.5584 times 10 to the negative 3 molar mercury. We can write this as 0.00455584 molar mercury. So this is the answer for letter A. All right. The next question: what mass of mercury chloride is formed in the reaction? All right. So from the given values in the problem, we can solve for the number of moles of chloride, and then we multiply it by the mole ratio between chloride and mercury chloride. Then we can get the mass of mercury chloride in grams. So let's start with this one. So that would be 0.0154 liter of chloride times its molarity, which is 0.0148 mole chloride per liter chloride. And then we multiply this by the mole ratio of chloride and mercury chloride. So that is 1 mole is to 2 moles chloride. And then we multiply this by the molecular weight of mercury chloride, which is 271.6 grams per mole. Right, so let's cancel all those units. This one cancels out, this one, and this one. So we're left with grams mercury chloride. So we can now calculate that. It's supposed to be 0.0154 times 0.148 divided by 2 times 271.6. So this is just equivalent to 0.031 gram mercury chloride. So this is the mass of mercury chloride that is formed in this reaction between mercury and chloride.